this question comes from the Unit 1 higher tier paper from a couple of years ago. It's also on the foundation tier, although it looks slightly different at the end. And it's all to do with calculation. It's to do with the amount of energy used by appliances and the cost of running those different appliances. So the first thing that the exam board does, just to settle us in, it gives us a huge amount of information up here, almost all of which we don't need at all for doing the question. So I'll let you sort of read your way through that, and then I'll just pull out how to do this particular question down here. So it says, use an equation from page 2. Now that one is going to be energy, or units used, is equal to power times time. And it's going to tell us on that equation sheet that power needs to be in kilowatts, not in watts, and that time needs to be in hours, not in minutes. And that's quite important as we go through the question. So we're going to take the power for 40 degrees, and that's going to be 0.5 kilowatts, because there's 1,000 watts in a kilowatt, times time, which is 90, but that's not 90 here, that's 1.5, because there are 60 minutes in an hour. It's a bit of a tricky question, to be honest, but it's quite doable once you know what you're doing there. So that's equal to 0.75, okay? Nearly forgot the 0 point as we were doing that, and that's units. And then the cost is equal to the units used times the cost, or the price I should say, per unit. So that's going to give us 0.75 times 16 from in the question, and that gives us 12 pence. Okay, watch out for doing silly things like doing it in pounds. There's no need. You can get away without doing any of that stuff. Okay. Right, so the next bit, so they pull out this piece from the article above. So the idea that washing at 30 reduces energy use by at least 40% compared with at any higher temperature, so washing at higher temperatures. And that's quite important, because if we come back up here, the first thing that we notice really is that the energy use is determined, really the only difference is in the time here. So the important thing is, how do the times compare to each other? So if we start with a nice easy one, if I switch from 50 to 30, I go from 120 minutes to 60 minutes. Now that's half. So I'm going to say for 50 degrees to 30 degrees, 50% saving. Okay, lovely. So far so good. Now if we come back up, if I go from 40 degrees to 30 degrees, I'm going from 90 to 60 minutes. Now, a little bit of cheeky maths will tell you that from 40 to 30, that's actually a 30%, it's actually a 33% saving of the thirds. So that's not 40%. So I need to say that at the end. So I'm just going to say it's invalid. So it's asking me to the validity. So it's invalid because from 40 to 30, only a 33% saving. Okay, so that's it for this side. We'll flip over for the rest. Then we've got a nice question here. This one comes up quite often as well, which is, if I save money on my household bills, that's a good thing, but why does reducing energy consumption also help the environment? So most energy comes from burning fossil fuels, and this, yeah, I think it's the best thing to say, this produces CO2, causing global warming. The important bit being that we're linking together the fossil fuels and the carbon dioxide emission from that process, okay? And then we've got a beautiful picture here of the ring main and a quick 1 mark question here. This is the bread and butter of anyone trying to just grab the easy marks. State which wire the fuse must be connected to. That's a learner, and that's a live wire, okay? You just got to learn that one. Describe the function of the earth wire. Now this one's quite good. So it provides a safe route for current to ground. Try and avoid using to the earth because that's in the question. So a safe route for the current to ground in case the metal appliance develops a fault and becomes live. Okay, that's it for that bit. And then we've got one last question here at the end, which is all to do with fuses. Now, the important bit about fuses is the fuse has to be bigger than the current you are trying to put through the fuse. So what we're going to do is just do a quick evaluation of this to find out what's going on. So this person is going to fit a 3 amp fuse because they've looked at this bit here. So from page 2, power is equal to current times voltage. So that's, we want the current here, so I equals P divided by V. So if we try that for the average one, so if we do 500 divided by 230, we get 2.17 amps. Okay, lovely. Everything looks fine because 3 amps is slightly bigger than that, so we should be okay. But if we try it here for this power one, so for the maximum power it draws, let's have a look what happens this time. So 2400 divided by 230, that's going to give me 10.4 amps. Now you'll notice, I'm sure, that 10.4 amps is greater than the 3 amp fuse that this guy's fitted. So investigate whether or not this is a suitable choice. No, because fuse will blow when at max power. Okay, there you go. As you can see, 15 marks. This was a huge chunk of this particular exam paper, nearly a quarter of it, in fact. So it's just about solving the little problems that come up and interacting with the information in the text. Okay, thank you very much.